So recently I've been working on an LGOAP plugin for Unity, and in this video I wanted to show the current progress of this project. If you don't know what LGOAP is, I'll link a few resources in the description that you can check out. So once you do that, come back and watch the rest of the video because it requires preliminary knowledge of at least goal-oriented action planning, if not layered GOAP itself. Just like any other AI model, this plugin uses a blackboard system where you can define the name and type of the keys, as well as whether they have an instant synchronized value, just like Unreal Engine 4's blackboards. Based on this world modeling, then, you can define your goals. For the sake of this video, we'll define two goals: watering the plant and patrolling the area. Based on the same world modeling, you can also define your scene. For the sake of this video, we have a few action opportunities available to the player. A water source from which an agent can pour some water if the source contains enough. A tree that an agent can water if it possesses some. If the agent waters it, it dries up after 20 seconds. It also has an icon to determine whether it needs water. Two patrol points that promise an agent to reduce its insecurity, but unlike the other two actions, this object won't deliver on its promise because we want the patrolling to be a persistent goal. So now that we have established the model of the world, let's go straight into the editor and see how the agent behaves. As expected, because its primary goal is to water the plant, it's going to first get the water from the source and it will water the plant, and then it will continue its patrolling until the tree gets dry again. And once the tree gets dry, it will attempt to water the tree again. However, this time, since the agent was already carrying some water, it does not need to go to the source and get some. And just as expected, when it needs to, it actually does go to the source and get the water. I also want to show how extensible this tool can be by complicating this problem and then solving it from the editor itself without needing to write any code. Consider this garden being locked behind a set of gates, and we want the agent to get through the door one way or another to water the plant. Firstly, we'll need to restructure our blackboard to account for the new possible states. Then we'll need to add an extra condition to the water source. Then we can create two ways to get through the door. An agent can open it with a key, or they can break open the door with a crowbar. Logically speaking, breaking down the door should have a higher cost. Then we will provide a way for the agent to acquire a key, and then the same for a crowbar. And just with these steps, we have remodeled our problem to suit the new requirements. Let's get into the editor and see how our agent behaves now. It will get the key and open the door and follow its routine of watering the plant and patrolling, unless we remove a way for the agent to acquire a key, in which case it will go for the costlier action to break open the door. So with this demo, you can see that this tool has been created with designers in mind. From not worrying about inputting string values to having a robust and easily extensible system that lets you create queries over a world state to be used for your goals or modifications of your world state to be used in your actions. On top of that, this algorithm has nearly zero garbage allocations after the first time the planner has run, and the whole setup runs on multiple threads using C#'s thread pooling system. You might be wondering what the layered part is in this video, and to that all I can say is that this tool has been built from ground up with LGOAP in mind, and so while the final version might not be ready yet, there are quite a few things that are ready to be used when this single layered planning system is turned into a multi-layered one, such as hybrid world state modifications that can also function as queries for the next layer. I will post the next devlog for this plugin to keep you updated once a reasonable amount of progress has been made. The current primary goal is to extend this system to properly support animations and such, with a few more things queued up, such as pooling to bring garbage allocations down to a complete zero before I begin implementing layered planning. There are also a few secondary goals that I have in mind, such as moving the planner to C# jobs system, but they have a very low priority. The primary aim for this tool is for a personal project that I have been working on, and so you can be sure that it will be thoroughly tested and debugged. In the meanwhile, you can download it from the GitHub repository linked in the description using Unity's package manager. If you would like to help with this tool or with the game that I am working on, or have any suggestions for this plugin, or even just want to discuss goal-oriented action planning, or game AI, or game development in general, or just games altogether, feel free to hit me up on Twitter at odium followed by 5 underscores. Thank you for watching.